Unit 4, Lesson 4, Example 3. So again, we're going to apply what we learned in the lesson. So, annotate the diagram with the given information. We're asked to do a proof. So again, I'm going to write my methods up top. This will be the video for the 2-column proof. So side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg are the methods that we have available to us. So first things first, let's annotate the diagram with what we are given. AD is perpendicular to BD, so I know that I'm going to have a right angle there. BD is perpendicular to BC, so again I know I'm going to have a right angle there, and they tell me that AB is congruent to CD. So again, let's look at our methods that we have available. They didn't tell us anything about AD and BC, so there's no way that I'm going to be able to get all three sides. Could I maybe get side, angle, side? Well, I don't have the two sides that form this right angle here, so no, because again, that angle has to be included or in between the two sides. They didn't tell me anything about any of the other angles, so that is out. And additionally, angle, angle, side is out. So we do have right triangles here, so we can use hypotenuse leg. And what we notice is that BD is a shared side with both of the triangles. So that is where we will get that. And again, to reference the lesson, notice if I mark these, I get side, side, angle, which is not a valid method. However, we can use hypotenuse leg because they are right triangles. So again, side, side, angle, not a valid method, but because this is a right triangle, we can use hypotenuse leg instead. So let's get our columns and our first statement and reason, which is the given up there. So they gave us that AB is congruent to CD, so if I look at my right triangles here, those are hypotenuses. They are across from the right angle, so technically we kind of have a little H going on, right? We have that. So now we need to make another statement. Okay, in order to use hypotenuse leg, we must state that these triangles are right triangles. So again, I'm going to put a little 1 and a 2 here, and I'm going to say that angle 1 and angle 2 are right angles. They didn't give us that these are right triangles. They didn't give us that these are right angles, but I know that these are right angles based on the definition of perpendicular lines. I can also say that perpendicular lines intersect to form right angles. So because 1 and 2 are right angles, I can say that triangle ABD and triangle CBD are right triangles. That's the definition of a triangle with one right angle, right? Definition of a right triangle. Okay, so I've stated that 1 and 2 are right angles. I've stated that the triangles are right triangles, and again, only right triangles have a hypotenuse. So all I'm missing in order to use hypotenuse leg is the leg, which would be BD. And we can say that BD is congruent to itself. It is a shared side in both triangles, and we know that that is the reflexive property. So do I have enough information now to prove triangle ABD congruent to triangle CBD? Yes. Triangle ABD congruent to triangle CBD. And the reason is hypotenuse leg. So just keep in mind, in order to use this, this must be stated in your proof before you can use it. And identify the rigid motions that would map one triangle onto another. So you can use some reflections followed by a translation. However, the easiest thing would probably be a rotation of 180 degrees at B, which will give me a triangle that looks like this. And then I would need to follow that up with a translation. So how would we say this? I can say a rotation. You could center your rotation at another point. I just happen to pick B. 180 degrees, centered at B. Followed by a translation. Or I can say a translation that will map point B to point D. Or I can give it a vector from B to D.